Problem number 13 was rated as the most difficult, and that problem asked for the fifth term in the expansion of x plus 8 to the n. Now, what does that mean? Let me digress for a second to clarify something. I just realized that the textbook has dumbed itself down to the point where this is not a mainstream topic included in the problem sets. As a result, it's going to count on the test only if you get it right. If you get it right, or if you get enough points that your performance on this problem is helpful to you on the test, we're going to count it. Otherwise, we would dismiss this problem and grade you based on the remaining problems on the test. So, okay, anyhow, let's see what this means, because it's not that difficult. It's a really good application of binomial counting. Okay, first of all, let's think, instead of x plus n to the 8th, let's think of what x plus n squared means. Of course, that means x plus n multiplied by x plus n. Now, what do we do when we multiply x plus n by x plus n? Well, everything here has to multiply everything here. So everything in either binomial has to multiply everything in the other binomial, meaning that we multiply x by x, we multiply x by n, we multiply n by x, and we multiply n by n. So, x plus n squared. We're going to think of this in a little bit different way than you've thought about it before. We're going to say that, okay, well, how many x squareds are we going to get when we end up multiplying this out? Well, we can choose an x from the first binomial, and we can choose x from the second binomial. There's one way to do that. There's only one x here, there's only one x here. So there's just one way to choose x from this binomial and from this binomial. So there's only one way to get x times x, which would be x squared. There's only one way to choose x from both of these binomial factors. Now, another thing that we could get is we can get x times n, which of course is the same as n times x. How many ways are there to do that? Well, we could choose, in order to get an x times n, we got to get x from one of the binomials and n from the other binomial. Now, it doesn't matter in which order they're chosen from the two binomials, because multiplication is commutative. If we choose then, say, n from this binomial and x from this binomial, it's an x times n, because n times x is the same as x times n. So what's going to happen is we're going to say there are two ways to do this. We could choose x from the first binomial and n from the second. That's going to give us x times n. And we could choose n from the first and x from the second. That's going to give us an x times n. So that we have two ways of getting x times n. And then how many ways are there to get n squared or n times n? Well, there's just one way. We have to choose n from each of the two binomials. So just one way to choose that. Now let's try to use that reasoning in figuring out x plus n to the 8th power. X plus n to the 8th power means, well, I've written it out, the binomial x plus n is multiplied by itself 8 times. Okay? Now, how many ways can we get x to the 8th out of this? Well, to get x to the 8th, we've got to choose x from 8 of these binomials. Well, there are only 8 binomials, so there's only one way to do that. We've got to choose x from this one, 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 and from this one. So there's only one way to do that. We choose n from each of the 8 binomials. So there's just one x to the 8th. Now, what about x to the 7th times n? Because it's possible to choose x from, let's say, the first 7 and n from the last 1. That's going to give us x to the 7th times n. Of course, it's possible to choose n from the first and x from each of the last 7, so there's another way. Well, it turns out there are 8 ways to choose n from one of the binomials and x from the rest, because there are n binomials from which you can choose the single there are 8 binomials from which you can choose the single n. So there are 8 ways to get x to the 7th times n. Now, what about x to the 6th times n squared? Now, that's the n to the 6th. X to the 6th times n squared. Maybe I said it right, but let's make sure we understand. Okay. Now, how many ways are there to do that? Well, we could choose x from the first 6 and choose n's from the last 2. We could choose x's from the last 6, choosing n from the first 2. Or we could choose n from the second and the 5th and choose x from all the others. There are many ways to choose 6 x's and 2 n's. In fact, what we're doing is we're choosing 6 of the 8 binomials from which to choose x. How many ways are there to do that? Well, the number of ways of choosing 6 objects out of 8, and the order in which they're chosen doesn't matter, is C of 8 6. So there's C of 8 6 ways to get x to the 6th times n squared. Now C of 8 6 is what? 8 times 7 divided by 2, which is 28 ways. You could list 28 ways. I'm not going to do that, but you could easily enough list them. Okay, well, the next thing we could get is x to the 5th times n cubed, and by similar reasoning, there are C of 8 5 ways to choose the 5 binomials from which you choose the 5 x's, and then choose the n's from the others. So this leads to the binomial formula, and you can, of course, read about that in your book. This is the thinking behind that formula. And remember, again, this is optional. If this problem won't occur on every version of the test, but it occurs pretty frequently. You won't always have 8, and it always won't be x and n. You could have different letters. If it occurs and you get it, then you get credit. If it doesn't help you, it doesn't count.